Real numbers x comma y satisfy x square plus y square is equal to 1. X square plus y square is equal to 1 is a circle with center 0 comma 0 and radius 1. X comma y satisfy this equation. That means x comma y is a point on the circle. That is our first understanding. Okay, let me take a circle, draw a circle, and this is my x axis and this is my y axis. Now I have circle with center 0 comma 0 and radius 1. So equation of this circle is x square plus y square is equal to 1. There are infinite points on the circle. Any point we take on the circle, that will act as one solution for this equation. What is asked in this question? There is an expression z which is 4 minus y divided by 7 minus x. We have to find maximum value for z and minimum value for z. What is x comma y? X comma y real number satisfying equation of circle. So I can understand x comma y as any point on the circle. So basically this point P is not fixed. X comma y can be any point on the circle. Then how do we understand z? When I look at this, it is resembling like this. Slope is equal to y2 minus y1 divided by x2 minus x1. Difference between y coordinates divided by difference between x coordinates. So we will take a point y2 is like 4, x2 is like 7. So let's take a point whose x coordinate is 7 and y coordinate is 4. Definitely this point would lie outside the circle. Now if we understand this AP slope, what is slope of AP? That is y2 minus y1 divided by x2 minus x1. This is only z. This AP line slope is only z. What is fixed here? Point A is fixed. Point P is moving. How is point P moving? Point P can be any point on the circle. So we have to find maximum value of this slope and minimum value of this slope. That is z max and z min. So that is our question. Let's redraw the diagram. I have circle with center 0 comma 0 and radius 1. There is a point A which is 7 comma 4 and P is any point on this circle. So P is moving. P can be here or it can be here or it can be here, right? So then each case, what would be slope of AP? So if P is here, AP line would be like this. This would be AP line. If P is here, then AP line would be like this. All right. Suppose if I take P here, then AP line would be like this. All right. So no matter, suppose if I take P here, AP line would be like this. So no matter how I take these lines, let me call this as line 1, line 2, line 3, line 4. No matter where I take point P, A is fixed, point A is fixed. This AP line, if we observe, this is always making what kind of angle with positive direction of x-axis? AP is making an acute angle with positive direction of x-axis. That means slope of AP, which is nothing but tangent of inclination. This is between 0 degrees to 90 degrees acute angle. So tan theta would be positive. Slope of AP is positive. When do I get maximum slope? And for AP, where should I take point P to get maximum slope? And where should I take point P to get minimum slope? See, if theta is acute, as theta increases, tan theta increases, right? Tan theta is slope. As theta increases, slope increases. Now, if I need maximum slope, that means inclination should be maximum. If I need minimum slope, inclination should be minimum. All right. Let's take the diagram once again. Now, where should I take point P to get least inclination? Okay. So, where should I take point P? Okay. Think about it in this way. How should I move this line to get maximum inclination And where should I keep it to get minimum inclination? Suppose if the line is like this, then I'll have maximum inclination. This would be maximum inclination when the point is here. And if the point is here, then I'll get minimum inclination. Okay. That means when point P is here or line AP is acting as tangent like this to the circle, here inclination is minimum. That means slope of AP would be minimum in this case. When inclination is maximum, this case slope of AP would be maximum. Slope of AP is Z. So Z will be maximum when P is taken here. When P is taken here, Z would be minimum. Maximum value of Z is capital M, is told as capital M. Minimum value of Z is told as small m. So how do I find small m and capital M? Small m and capital M are slopes of tangents to the circle from the point A 7, 4. All right. So we have a circle. Equation of the circle is x square plus y square is equal to 1. We have some point which is a 7, 4. I need slopes of these two tangents. So any line passing through 7, 4 and having slope m would be in the form of y minus y1 is equal to slope times x minus x1. And I need this line to act as tangent to the circle. So that means perpendicular distance from center is equal to radius. Okay. So what is the equation of this line? Y minus 4 is equal to mx minus 7m. That means mx minus y plus 4 minus 7m is equal to 0. How to find perpendicular distance? How to find OF? Let's find OF distance. This is the line equation. Line equation we have here. Formula for perpendicular distance: modulus of ax1 plus by1 plus c divided by root of x coefficient square plus y coefficient square. Perpendicular distance from center to any tangent would be equal to its radius. That means we got modulus of 4 minus 7m is equal to root of m square plus 1. On squaring both sides, we get 16 plus 49m square minus 56m is equal to m square plus 1. So 48m square minus 56m plus 15 is equal to 0. Let's factorize this. 48m square minus 36m minus 20m plus 15 is equal to 0. If I take 12m common, this would be 4m minus 3. And if I take 5 common, it is 4m minus 3. So 12m minus 5 into 4m minus 3 is equal to 0. That means the m value is 5 by 12 or 3 by 4. So of course 5 by 12 is less than 3 by 4, right? So we got two slopes. What conditions we have used? Tangent is passing through 7, 4, right? Tangent passing through 7, 4. I'm saying its slope is m. We got two slopes because there are two tangents passing through 7, 4. One slope is 3 by 4. Another slope is 5 by 12. Which is smaller among them? 5 by 12. Larger among them is 3 by 4. So from point 7, 4, we can draw two tangents to the circle x square plus y square is equal to 1. And these tangents slopes are like this. So what is capital M? Capital M is the maximum slope of the tangent, right? So capital M we got it as 3 by 4. Small m is the minimum slope of the tangent from 7, 4 to the circle. That is 5 by 12. So what is demand of the question? Z max, that is the maximum slope of AP, that is 3 by 4. Z minimum, that is minimum slope of the AP, that is 5 by 12. They are asking us to calculate 2 times capital M plus 6 times small m, which would be 2 times 3 by 4 plus 6 times 5 by 12, which is 3 by 2 plus 5 by 2, which is 8 by 2, which would be 4. So this would be our answer to this question.